you say. A G, you say. Ooh. Setting you up. Setting you up.
N.
Uh-huh.
Oh, wait. Discriminant.
So close. Say it again.
Discriminant.
This something. Still got words to choose. You have some of them you might be able to throw in there right now.
S.
Uh-huh. So you got two hands, you got two legs, you got an eye, and a smiley face. So you got plenty of space to wiggle, but see what you get.
Discriminant.
Close. You're never gonna forget this now.
C.
Okay.
For sure.
Uh-huh.
Discriminant. Oh my god.
Oh man, right there at the end. All right, discriminant it is. Yep. So that told me exactly what I was thinking. Like, all right, what's the discriminant telling me? So I mean, you can kind of use a quadratic formula right off the bat, or you can just test it on its side. But as soon as I simplify all of this, I basically have 1, then -4, -4 times -2 is 8, +8, but then the +8 multiplies with the -7. -56. And what happens? The discriminant's inside as a square root of a negative number. And what do we know about that?
It would be imaginary.
Imaginary. So I did the follow-up and I did the graphing bit, given that I have a calculator handy. And I think if I zoom in a bit closer, because this graph didn't really give me a good space here, we can kind of notice it. That's right at the top there. But I'm gonna zoom right there. Barely doesn't touch it. Doesn't touch it at all. No x value, no answer. Basically, no answer. NA, not applicable, or no x-intercepts. No roots, however you want to call it, right? That's the check there. The first check with the AC method to see if we can actually factor it. Well, 14 doesn't really get to x. So that's also why a good check, not to spend too much time trying to hunt down the actual roots or the factored form, because you might find something interesting in a quadratic discriminant. And now you're not going to remember that. You're not going to forget that word. All right. Let's do another. Bring me another. Boom. Go ahead. How do we start this one?
This would be another link that is maybe just
hopefully the AI is a little bit better on this one. Let's see. So follow that same sort of is. That's a good starting place.
It would be parentheses 3 plus W.
So okay, starting and building it up. So L is 3 crew, but missed something.
2W.
2W. Then we'll think about our area. We can plug in L of this into this. 3 plus 2W, and then times W, right? And 65 is the area. And then we begin. That's the setup, and now the process. Distribute as before. We already know we're going to move that 65 over to make it a negative. And set it equal to 0 so we can factor and solve. Then maybe shuffle it around a bit so we don't get confused by the order of our numbers here. And starting point next.
I was gonna say AC, but the numbers would be too big.
Not a problem if you do the little factoring thing. But then again, it is your choice, right? Because if they don't give you the instruction of factor versus use quadratic versus just solve any way you want, right? But sure, okay, maybe number's too big, but remember, if you do AC method, you don't have to multiply these two. You can, but that's a good starting point right there. You can say, all right, that's 130, sure. But you can also just do this. Take it apart further, right? It's already step taken apart. The one thing about AC method is we're forced to think about the multiply spot, like, oh, I gotta multiply them and then take it apart. Not really. You can definitely multiply to see what it is, but your starting point can still be the two pieces, the A and the C. Now, if I was to run a little combination, what would be a good combination between these three that would fall for that CW in the middle? And also one of them is negative, so I'm gonna give them negative to the 2 for now.
Oh, 13 times negative 10?
True. Automatically. Add those together instead. Well, technically speaking, I always do this little double check on the right side. I multiply, so that's going to be a negative 130, so it matches. We're on the right track. And on the left, we're going to do addition, and that's going to bring us to 3 for the middle. Then what?
The numbers that we get for this is 13 and negative 10. And so we can plug it in as the 3W.
You can split the 3W, would be the correct terminology, right? To the sum of these two numbers that we found. So that'd be 13W. Plugging in would be like a replacement of a variable, so that's where you can kind of get confused with the two. But if you say split the sum of 3W into 13W minus 10, that's what's happening here. Drop the rest because nothing happened to those. Then what?
For the left side, we could factor out a W.
Yep, W sounds fair.
And it would be 2W plus 13.
Cool.
And then for the other side, we could factor out a negative 2 of 5.
Negative 5.
And then it would be 2W minus or plus 13.
Okay, good catch. Yeah. And there it is. There's your two pieces. W minus 5. 2W plus 13 equals to 0. And then finally, to find the width here, what do you think?
One would be W equals positive 5. And the other one would be a negative 13 over 2.
Negative 13 over 2. And what do we think about, again, when we see that realistic garden potential answer and then some value that's giving us a length of a negative?
It has to be W equals 5.
Right, because there's no such thing as a negative length. Meters. Yeah, there's no such thing as negative 13 over 2 meters or 7.5. No. negative 6.5 meters. So bam, that automatically gets disqualified from a realistic answer. And we choose W is 5. So that's one thing we have for sure. And then finally, the other... Oh, that's all they wanted, actually, the width. But if they wanted both measurements, we can then do what? Plug in the 5 up here. And 5 times 2, 10, 13. That's interesting. 13, but not 13 over 2. 5, 10, 3, 13. We saw 13 down there, too. That's a weird one. They keep matching sometimes. Okay, cool.